So let's have a discussion with motion in a straight line. Now we are living in a 3D space, but in your screen you are just being able to observe in a 2D space. So let's have a try. This is z-axis that is coming out of your screen and inside your screen. This is your y-axis and this is the x-axis. So say suppose this is a object of mass m and it's moving in a direction somewhere over here, say in a r direction at the point P. Now individually you can break this into its x component, into its y component and into its z component. The movement can individually be broken into. So that is, even if you study the one-dimensional motion for each axis and then you combine them and you combine x plus y plus z, then you will have the combined motion of the mass m going at the direction of r. So even if we study the one-dimensional motion, we can easily apply this to our 3D space. So let's study the motion of an object in a straight line, and this is also known as rectilinear motion. A motion in a straight line is also known as rectilinear. This is rectilinear motion. That is in a straight line. So when a motion in a straight line comes, we need to understand certain terms. The first term is your displacement. So this is displacement. Now say suppose this is a point A and this is a point B. Our object has been displaced from A to B. Now it may mean that the object may be carried over here to a point C, then again brought over here to a point D, to a point E, and then finally placed to the point B. So when you talk about the initial and final displacement, this is initial and this is final. When the term displacement comes, you will only be talking about where the initial position was and where the final position is. So the displacement is just this distance d. This is what is known as displacement. Now, another concept that comes is your frame of reference. Frame of reference. Now, before explaining to you what is a frame of reference, let's take an example. Say suppose you have two trains. You are sitting and there is a third person who is sitting in a house. So this is the person who is sitting in a house. And there are two trains. One train is going in this particular direction. The other train is moving in the opposite direction. So these are the two trains that is coming in an opposite direction. Now if you observe, this person is sitting outside the frame of reference to that person who is sitting inside the frame. So what a person is observing inside the frame is quite different from what a person who is sitting outside. Let's have a look why. Now if a person who is sitting inside the moving train moving with the velocity v, if all of the surrounding is vanishing, he only sees this particular train, then what he will observe is that this train is coming towards him. See, this is the velocity v1, this is the velocity v2. This train is moving with the velocity v2, this train is moving with the velocity v1. So if this train is moving where the person is sitting, he will say that this train is coming towards him at a much faster rate, that is v1 plus v2. Now why does it happen so? Why does he feel that this train is moving with this much velocity? Or the other way he can perceive is that if he refers this train to not be moving, he will see that he is coming towards this train with this much velocity. The practical example is that if two trains are moving alongside each other, they are moving with great velocity, say V1 and V2. And say suppose V2 is greater than V1, that is this velocity is greater than this one, then slowly and steadily this train will cross this particular train, it will cross him. Now if you look at the passengers who are sitting at this train, you will see that you can easily observe them. You can easily observe them, the reason being that their velocity, their relative velocity gets subtracted. This is V2 minus V1, and so the relative displacement between them is smaller. So by having or by looking at this example, we can easily verify the relative speed and the relative distance. So if a person is sitting in his frame of reference, that is in the moving frame of reference, say suppose this is his frame of reference. So what he will observe is that this particular object is moving towards him with a velocity v1 plus v2. Now if it was moving in the same direction, he will say that this is moving in a very very slower rate, that is v2 minus v1, because of this two's relative motion, it is observed that the motion is decreased. But this is not so. In real life, this is not happening. All of them are moving with their exact same velocity. So the difference is because of the relative frame of reference and relative velocity. So for him, it is a different scenario, and for a person who is sitting outside this system, let's say this is a system, and for a person who is sitting outside all of this, he sees that he's moving into the velocity v2 and he's moving with the velocity v1. So this is what we can understand by frame of reference.